Honorable Respected Chairman of Varnagak Shikshan Mandal, Dr. Vinaraji Kore Saukar, Honorable Administrative Officer, Professor Dr. Vasanti Rasam Madam, In charge Principal of YC Varna Mahavidyalaya, Varnanagar, Honorable Professor Dr. P.S. Chikodekar, myself Dr. B.S. Shirke, Department of Chemistry, YC Varna Mahavidyalaya, Varnanagar. Here I am going to present the concept nanotechnology and the nanomaterial. That nanomaterial, nano means, it is a Greek word, and that nano means a dwarf. It is a very small. And the nano means, the nano is 10 raised to minus 9. That means nano is equal to 1 upon 10 raised to 9. It is very small. That nanomaterial are commonly defined as the materials with particle size in between 1 to 100 nanometers in one of the dimensions. That is 1 nanometer is equal to 10 raised to minus 9 meter. For examples, that is the proteins are having 5 nanometers, about 5 nanometers, DNA are about 10 nanometers, blood vessel pores are about 20 to 50 nanometers, that carbon nanotubes are ranging about 50 nanometers, and that human hair diameter is about 5000 nanometers. That nano, that it is Greek word, that nano, N for novel, A for approaches, and N for new, and O for opportunity. That is novel approaches, new opportunity. That photo indicates that this is the research Feynman, scientist research Feynman. He has delivered the lecture in Rice University in 1959, and he told that there is a plenty of a room at the bottom about the nano. And what is nanotechnology? That nanotechnology means creation of functional materials, devices, and system through control of nanoscale material in 1 to 100 nanometer, exploiting novel properties and phenomena at all length scales. Then the history of nanomaterials. These are the examples in 4th century, that is in late Roman, that Roman can use to drink a Madhira, we can say Madhira, and that these are the 2 cups, that is Lycurgus cups. That Lycurgus cup is an well-known example, that is historical examples of nanomaterial in 4th century. It appears at normal lighting, it appears a green color, whereas when it illuminating the light, it shows a red color. And this is due to that cage material of that Lycurgus cup is silver and gold nanoparticles. And due to surface plasma phenomena, it shows a red in color. Then milestone in nanomaterials. In 1955, that is synthetic diamonds. 1959, that is the Richard Feynman delivered the lecture in the Rice University, and he told that there is a plenty of a room at the bottom. In 1974, that first molecular electronic device is patented. In 1981, that is scanning tunneling microscope. In 1985, that is buckyball, that is fullerene, discovered at Rice University. That atomic force microscopy is invented in 1986, and in 1987, first single electron transistor are created. In 1991, that carbon nanotubes are discovered. In 2000, US launches a national nanotechnology initiatives, and in 2001, 2 ITRI Nano Research Center are established. Then the classification of nanomaterials. That the nanomaterials are classified by their structure, by their morphology, and these are classified such as nanotubes, nanowires, nanocrystals, quantum dots, and other nanoparticles. These are some examples, that is quantum dot, diamond, buckyball, that is carbon-60 fullerene, carbon nanotubes, and these are the nanowires. Then approaches for the synthesis of nanomaterials. There are two types of approaches for the synthesis of nanomaterials. That is, one is the top-down approaches and another is the bottom-up approaches. In top-down approaches, breaking down matter into more basic building blocks, whereas in bottom-up approaches, building complex system by combining simple atomic level components. Mostly that the chemist are prefers a bottom-up approach for the synthesis of nanomaterials. Then there are various methods for the synthesis of nanomaterials. These are some methods I have given here. Some that is colloidal method, Sol-Gel method, microemulsion technique, solvothermal method, chemical reduction method, electrochemical method, chemical vapor deposition methods, microwave assisted Sol-Gel method, etc. etc. Then first that is colloidal method. In colloidal methods are simple and well established wet chemistry precipitation process in which solution of the different ions are mixed under controlled temperature and pressure to form insoluble precipitate. For metal nanoparticles, the basic principle of colloidal preparation were known since antiquity. For example, that is for preparation of gold colloids. However, that in 1857 that Faraday has published the results in his experiment with gold. He prepared a gold colloidal by reduction of aram chloride solution with phosphorus. Today, colloidal processes are widely used to produce nanomaterial like metals or metal oxides or organic and in pharmaceuticals. This is the flow chart for the synthesis of sol gel process. In the synthesis of sol gel process, that is the precursors. That precursors are dissolved in particular solvent and to form a sol. And then dehydration of that sol will give gel, and gel by rapid drying will give aerogel, and sufficient by using organic will give zero gel, and then calcined will give uh, some ceramic dense material, that is the nanomaterial. Then another method, that is the chemical reduction method. In chemical reduction method, metal nanoparticles can be synthesized by chemical reduction method. In this method, precursor solutions such as metal salt solution is treated with suitable stabilizing agent are added. After drying treatment, metal nanoparticles are formed by this chemical reduction methods. Then another method is the chemical electrochemical method. In electrochemical method, it is a very simple and attractive method because the process is very simple and effective. It involves electrolysis of electrolyte by passing electric current to coat an electrically conductive object with thin layer of metal. There is a huge variety of possibility of reduced ions. In this process, deposition of metal ion in the form of thin layer on cathode takes place. So this process is called as electrodeposition process. That electrodeposition is depend upon current density and time for which the current flow. Then the synthesis material should be characterized. If we observe on the right hand side, this is an funny examples, that is the Chinese challenge, and some questions below it. That is, which student is sleepy? Find the twin brothers, find the twin sisters. How many girls are they in the photos? Which one is the teacher? Uh, the answer of these questions are difficult to give because they all are students are sleepy, all likes are twin brothers, all likes are twin sisters, and all the questions are difficult to answer. Therefore, synthesized material must be necessary to characterize. Then it is easy to identify that material. There are various methods to characterize of synthesized nanomaterials. That XRD techniques, electron diffraction, XRD Raman spectroscopy, scanning electron microscopy, transmission electron microscopy, another AFM, gas absorption analysis, and then chemical composition, that is XRD, IDEX, elemental analysis can be done by IDEX, uh, then NMR, Raman, IR, atomic emission, absorption, fluorescence. These are the various characterization technique to characterize the synthesized nanomaterials. Then the applications of nanotechnology. That nanotechnology can be applicable in the various fields such as next generation computer chips, kinetic energy penetration, better insulation material, improved HD TV and LCD monitors, harder and more durable cutting materials, high power magnets, pollution cleanup materials, another that is a greater fuel efficiency for cars, stronger bio-based plastics, higher quality medical implants, home pregnancy test, cancer treatment, etc. etc. Thank you.